In the previous video, we calculated the perfect velocity that's going to keep the car on the road and not slide up and down. So the velocity was v equals to square root of the radius times gravitational acceleration times tangent of theta. Alright. Now that velocity, this velocity is going to keep the car on the road and not slide down. That's what, when there is no friction. There is no friction. This is what's going to happen. This is the velocity that we need, that the car needs to be on the road, not slide down, slide up or down the road. So that is when we don't have any friction. It has to be exactly this velocity. Now what happens if we decrease, if the velocity was less than the square root of Rg tangent of theta? So in this case, it means that the car is going to slide down. Okay, so if we decrease that velocity, that the car needs to be, that exact velocity that the car needs to stay on the road, if we lower that, then it's going to slide down. But what's going to keep it on the road is some friction. All right, we're going to have a friction that pulls the car up to prevent it from sliding down. Now, in this case, we're going to have a friction. So let's put all the forces in and see what is the velocity that's going to keep the car on the road when it's less than the perfect velocity that we had. Right? So let's say you have, banked curve, and then let's say this is the angle, and then the car is right here, and this is the road. So the car is going around on the circle, okay? And this is the center. The center is gonna be over here. So this is my center. And this is the radius, okay? And that's the car. So let's represent the car by a dot. So the car is going to accelerate to the center. It's the centripetal acceleration that we were talking about in the previous video. Okay. So we're going to need the forces that are applied to the car. The first one is the gravity, the force of gravity. Fg equals to mg. Then you're going to have a normal force that's perpendicular to the surface. So it's going to go up this way. So that's Fa. Right. Now we have another one because the car is going to slide down. If we reduce, remember, the perfect velocity that we needed for the car to stay on the road is the square root of Rg tangent of theta. That was derived in the previous video. Now, if we lower that velocity, it means that the car is going to slide down. Okay? So we're going to have some kind of friction that prevents it from sliding down. And that will be the other force that we need the friction, F. We can call it F for friction, lowercase f, friction. Okay, so those are the three forces now we have. Now, again, the xy coordinate is going to be on the same direction as the acceleration. Okay, so it's going to be, this is my x coordinate, and this is my y coordinate. X, y. Alright, now, every force, those three forces that we have to have the x component and the y component, because this is where my x coordinate is the same direction as what acceleration is going to. So it's going on the x on this axis. Okay? So we have to follow what acceleration is doing. Acceleration is centripetal, going to the center. So that means my x coordinate has to be on the same direction as the acceleration. Okay? So for these three forces, they have to have an x component and y component. Now, the gravity, the force of gravity is already on the y-axis, so we're not gonna decompose it. We're not gonna break it down because it's already on the y direction. But then the normal force and the friction force, we have to break them down into forces. So let's do the normal force first. I'm gonna use the green for the normal force, so you have the y component and the x component. We're gonna call this F. I'm gonna put it inside F and Y, and then F and X. Alright, and then let's put in the angles. So this is where the theta is. That means that it goes here, alternate interior angles, and now it's gonna be over here. And the same thing here. This angle is vertical angle to this one. Vertical angles are congruent, right? And then we're gonna decompose the friction into component, the x component and y component. I'm gonna use a different color. So this is the x component of the friction. We can call it F, X, and then the y component of the friction is F, Y. Alright, we have all the forces we need. Okay. Now we're gonna do x direction. We're gonna put all the forces, we're gonna calculate all the forces in x direction, and then we're gonna calculate all the forces in the y direction. Alright. Now for the x direction, we're gonna have two forces. We have the x component of the normal force and the x component of the friction. Alright. So let's do that. The first one is F and X. And because the F and X is opposite together, we're going to use sine. So it's going to be F and sine of theta. And then the X component of the friction is going to be adjacent. It's an adjacent, so we have to use cosine. Okay? So this is going to be F X is going to be FF cosine of the angle theta. Alright, what else? Now, there is one more thing, the relationship between the normal force and the friction. Okay? You need to know that F of friction is equal to the normal force Fn times mu. By the way, the mu is the coefficient of friction. Now remember, we have to have a friction in this case in order to avoid the slipping down. All right. If you don't have a friction, then it's going to slip down if you lower your perfect velocity. Remember, you have to have a unique velocity that's going to keep the car on the road. But if you lower it down, then in order for you, in order for us to avoid slipping down, then you have to have a friction that pulls it up. All right? So that's the idea. Now let's do the y direction. On the y direction, we have the mg, which is already on the y-axis, so we don't need to break it down. So we have fg equals mg. And then also we have the y component of the normal force, and then the y component of the friction. So we're gonna have three forces, in two of them going up, and one, the force of gravity going down. All right. So let's find the F and Y. The F and Y, because it's an adjacent of the angle, so we have to use cosine. So it's going to be Fn cosine of the angle. All right. Now the friction, the y component of the friction, this one. All right. Because it's opposite to the angle, you have to use sine. So Fy is equal to Ff cosine, sine of the angle theta. And we have our three forces. Now, next is we need to use the Newton's second law for both direction, x direction and y direction. Okay, so let me do the x direction first. So we're going to do the sum of all the forces in the x direction is equal to m. And remember, we have a centripetal acceleration, which is going to the center seeking. All right, and that we already know it's v squared over r. So we're going to replace AC by v squared over r. Okay, so the x component of the normal force is going the same direction as the acceleration, so it's going to be positive. All right, so we're going to write Fn sine theta and then the x component of the friction is going the opposite way, so it's going to be negative minus the ffx, which is ff cosine theta minus f cosine theta. All right, and then we're gonna make that equal to, because those are the only forces in the x direction. Okay, so it's gonna be equal to mv squared over r. Remember, we're gonna replace AC by v squared over r, so it's gonna be mv squared over r. All right, so we're gonna leave this for now. We're gonna leave it like that, and we're gonna go and work on y direction. Okay, because we're gonna use both in order for us to have an expression for the velocity. We have to use both directions. All right, now on the y direction, these two forces, the y component of the normal force and the y component of the friction, those two forces, they have to balance out. They have to balance the gravitation, the force of gravity. They have to balance it. All right? Because there is no acceleration in the y direction. Okay? The car does not accelerate up and down. So these two forces, they're going to balance out the force of gravity, which means we're going to write it in the equation. It's going to be the two positive forces, Ffy, which is Ff sine theta, okay, Ffy, plus the other one that's also going up, so it's going to be positive, which is the Fny, so it's going to be minus Fny is equal to Fn cosine theta, so it's Fn cosine theta. And then you're gonna, oh no, sorry, I'm sorry, Fn cosine theta, because they're both going up, so it's positive plus, all right? The Fny is up, and the Fy is also up, all right? Fny, which is Fn cosine theta, and Ffy, which is Ff sine theta, and then you're gonna balance out the force of gravity, which is mg. And you're gonna make it equal to mg. Alright, so we're gonna work with these two equations. We can call this equation 1. And we're gonna call this equation 2. Somehow, we're gonna put them together as a system of equation and try to get an expression for the velocity. And that velocity will be the velocity that is gonna avoid slipping down. That will be the minimum velocity that you should have, okay, in order to prevent the slipping down. All right. So what I'm gonna do, I'm gonna raise this. Now, the FF, it's gonna be replaced by Fn mu. Remember? Because we have this formula. Ff is equal to the normal force Fn times the coefficient of friction. Alright? So we're gonna replace Ff by that Fn mu. So Fn mu sine theta plus Fn cosine theta equals mg. Alright, so I got rid of the friction force and I replaced it by something that has Fn. Alright, and then what we're gonna do is we're going to factor out the Fn. Remember, they have Fn, so we can put Fn as a common factor. Okay. And then we're gonna come here. Well, let's replace the FF here too. Right? Because we have Fn. Let me make some space here. So I'm gonna replace the same thing I did for the equation 2, I'm gonna do it for equation 1. I'm gonna replace FF by Fn mu. So I have Fn sine of theta minus Fn mu cosine theta, and then equals to mv squared over r. So now, equation 1 and equation 2, I don't have the FF anymore. I have everything in terms of Fn. Alright, so what I'm going to do is I'm going to factor out the Fn from here. Alright, so this is where I have my velocity. That means I have to factor out the Fn and then replace the Fn in this equation. So I'm going to work on the other one. I'm going to factor out the Fn. So I have Fn times mu sine theta, okay, plus cosine theta. So I factored out the Fn term, okay, Fn, I put it outside, and that should be equal to mg. And now I'm gonna isolate the Fn by dividing both sides by mu sine theta plus cosine theta. So I'm gonna get the Fn by itself. Fn is gonna be mg when I divide both sides by mu sine theta plus cosine theta. This term here, both sides, and I'm gonna get Fn by itself. Mg over mu sine theta plus cosine theta. Alright, so I'm gonna leave this Fn and I'm gonna replace it into this equation right here. Alright? This way we're gonna have because I need to keep the v term, the v, that's what I'm looking for. So I'm going to take this expression and replace the fn. But first I'm going to have to factor out the fn there as well. So let me erase over here. Alright, so I'm going to take this equation and factor out the fn. I have fn. Alright, it's all algebra. Fn, factor out fn. Then inside, I'm going to have sine theta. Sine theta minus mu cosine theta, because the fn is out. Minus mu cosine theta equals mv squared over r. Alright, so I got that from this equation. Alright, all I did is I put the fn out. Alright, now I'm gonna take this expression here and then replace the fn by this expression. Alright, so I'm gonna use a different color. So I'm gonna use the fn, this expression, which is mg over mu sine theta plus cosine theta, and replace it in fn. So I have mg, okay, mg over mu sine theta plus cosine theta. Alright, so mg over mu sine theta plus cosine theta, that's the fn. Now I'm going to multiply that by sine theta minus mu cosine theta. Alright, and equals to mv squared over r. Okay, the first thing you notice here is the m. You have m here and m there, so they're gonna cancel each other out. Okay, so we're gonna cancel the m because it's on both sides. Right? So m and m cancel out. Alright, now let me erase the left side because I have what I need. This is what I need. Okay, so I'm gonna erase the left side. Alright. And now we're gonna make some space to complete the problem. Alright. So this should be enough space to complete the problem. Alright, so let me just use this nice color. Okay, so the first thing we have to do, just like we did in the previous video, we're going to multiply both sides by r. So we're going to isolate the v squared. So multiply both sides by r. Okay, so multiply by r, and the r and r is going to cancel out. So we're going to end up with v squared equals, remember, we're going to multiply this by r, and this equation by r, the r cancels out. So you end up with v squared equals, now on the right side is going to be rg, and then this stuff here, which is times sine theta minus mu cosine theta divided by mu sine theta plus cosine theta. There you go, we're almost there. Now the only thing left is to take square root both sides. Take square root of both sides. So we're gonna have v square root from all this stuff here, which is rg. Multiply that and divide. So the top part is sine theta. Sine theta minus mu cosine theta divided by mu sine theta plus cosine theta. There you go. So this is the velocity that you need, the minimum. This is the minimum velocity you need to prevent the car from slipping down. Alright? And if you want to like a number, the velocity is a number, then we have to have the theta, we have to have the r, the radius, and then the gravitational acceleration. If you have those three variables, then we can get a number. Okay, that's it.